Hi everyone, welcome to today's lecture. So this is physics and we're still looking at vibrations and waves. So this is lecture 7 under vibrations, and to be specific we'll be looking at sound waves. So we're going to discuss what a sound wave is, what causes a sound wave, and then apart from that we'll look at the sound ranges, the speed of sound waves, the intensity of sound waves in decibels. Then apart from that we'll also discuss the intensity level. This is a formula. The intensity level of sound in the intensity level of sound, yes, in decibels. Alright, so tonight we'll not look at the Doppler effect. We're going to discuss the Doppler effect in the next slide, which is lecture 8. Yeah, so look out for lecture 8 on my channel, as it's going to be posted on Monday. Yeah, so that's why you're going to find the Doppler effect well explained. Okay, so let's quickly get into business. So we'll start first by defining what a sound wave is. Then after defining a sound wave, we'll look at other subtopics about sound. So what you have to understand about sound is that nothing in this world or nothing can produce sound without vibrating. In other words, sound is produced by anything that is vibration, that is undergoing the vibration, or anything that is vibrating produces sound. So sound and vibration, they are, let me just say, vibration is what gives birth to sound. So without anything vibrating, you don't expect sound to be there. So for a person to speak, it means that there has to be something vibrating in them. For anything to produce sound, there has to be a vibration. This is the reason why we define sound as a wave that is just under a longitudinal, in short. So it's just a longitudinal wave which is produced by a vibrating source, in short. So if something is to produce sound, there has to be a vibrating source somewhere. So if you see any alarm producing sound, just know to say there's something vibrating there in the alarm. Yeah, so that is what we mean when we talk about sound. So sound is just a longitudinal wave that is produced by a vibrating source. So an example of a sound wave is a tuning fork, and we have vibrating vocal cords. Yeah, so we have all those things as examples of sources that can produce sound. Okay, so let us look at the sound ranges. So sound ranges, we have sounds that are less than 20 hertz. By the way, sound is measured in hertz, and the symbol for hertz is simply just so sound is measured in hertz, and then the symbol for hertz is simply just H small letter Z, like that. So sound is measured in hertz, and then when we talk about the sound that is less than 20 hertz, sound that is less than 20 hertz is simply called, so this type of sound is or this range of sound is known as infrasonic sound. So this one is infrasonic sound, and then there's also sound which ranges from 20 hertz to somewhere 20,000 hertz. So this sound range is known as the audible sound. So this one is known as the audible sound. And then we also have the sound range which ranges from this same 20,000 going up, which is just rather, this one was a less than symbol. We're supposed to do this, and then I made an error there. Then the greater than symbol, so meaning any sound that is greater than 20 hertz is called ultrasonic sound. So ultrasonic sound is simply just the sound range which is from 20,000 hertz, not really 20 hertz, but 20,000 hertz. Yeah, so sometimes they'll just say 20 kilohertz. It also means the same. Okay, So this is what I was just talking about. So I said a sound range that is less than 20 Hz is called infrasonic sound, and an example there is the earthquake sound. And then apart from that, we also have sound which ranges from 20. It ranges from 20 to 20,000 Hz or 20 kilohertz. This one is called the audible sound waves. Then we have the frequency range that is above 20,000 Hz. In other books they will write it as 20 kilohertz. That is called the ultrasonic sound waves. All right, so let's look at the sound. Let's look at the sound waves in. So let's look at the sound waves, or rather the speed of sound waves in liquids, solids, and the air. So what you have to understand is that the sound moves at a different speed. Sound moves at different speeds depending with the medium that it's passing through. So the way sound can move in a metal is different from the way sound can move in water. So in liquids, sound is the velocity of sound is found by using the formula. Velocity is equal to the square root of the bulk modulus of that liquid divided by its density. And then in metals, in metallic substances, the velocity of sound is measured, or rather is found by the square root of the Young's modulus over the density. So the bulk modulus and the Young's modulus, these two are just constants. They'll be given to you in an exam or in a test or anywhere you're solving that, or you can search it from Google. And then the sound, the velocity of sound wave in the air. So this one we said liquid. Then here we said this is metallic. So this one, the Young's modulus and the bulk modulus, these are properties of metals. So the sound wave in the air is found by this formula. This is just the speed of light. The speed of sound in the air times. This is found. This is the velocity of sound waves in the air. It's given by 331 multiplied by the absolute temperature divided by 273 Kelvin. So this absolute temperature should be a temperature in Kelvin. So we discussed in thermodynamics to say whenever you hear about absolute temperature, we're simply talking about the temperature that is in Kelvin. So here, whichever temperature that you've been given, make sure that you convert that temperature to kelvins before you use it in that formula. So let's look at what I'm just talking about. So sound waves in liquids. The speed of sound depends on the bulk modulus of the fluid and its density. So the rho that was the denominator there, that is the denominator here, is simply just the density. Then this capital letter B there is the bulk modulus. Right. So let's look at the speed of waves, sound waves in metals. So the speed of sound waves in metals is found by using this formula which I wrote on the screen. So this Y you're seeing here is not really Y. It looks like gamma. This one is the Young's modulus, and then we have the density which is rho there. So it also depends on the density of that particular metal. So this is the Young's modulus, and then we have the density of that particular metal that that sound is passing through. Okay, we also have the sound waves in the air. So the sound waves in the air, for sound traveling in the air, the speed of sound depends on the temperature of the surrounding medium. So this is the formula which I just wrote there. Of course, this 331 is the velocity, that's why it has meters per second. Okay. This one is the speed, that's why it has meters per second. Alright, so this is the formula that I wrote, which you also have to know. Alright, so where T is just the absolute temperature, meaning it has to be in kelvins. Okay, so let's look at the intensity of sound waves in decibels. So one thing that you need to understand is that um, the human ear has the maximum intensity of sound that it can detect, and rather it has a minimum it can detect, and it has a maximum that it can tolerate. So it can only detect the sound that is above 1 times 10 to the power negative 12 watts per meter squared. The intensity, so the intensity that a human ear, the intensity of sound that a human ear can detect should be should be in this range, from 1 times 10 to the power negative 12. So this one is a negative, let me just write it properly. So this one is a negative 12 watts per meter squared to 1 watts per meter squared. So this is the intensity range that the human ear can detect. So it cannot exceed 1 watt per meter cube. When you just exceed this, expect your ears to start paining. If not that, you can even begin to have problems with ears. Yeah, so be careful with the type of sound that you are listening to. And then apart from that, it can only detect the sound wave that has at least the intensity of 10 to the power negative 12 watts per meter squared. So you also have to know this one. So this one you have to know it because there's a formula that we're going to be using it almost every time we've been asked to find the intensity level. So the intensity level is simply just given by this formula, 10 log, and then yeah, so I was saying the intensity level. Okay, so this is what I was just talking about. Then the intensity level is given by this formula, beta, which is just the intensity level is equal to 10, and then we have log intensity over I naught. So this I naught is the one that you this is the one that I was saying you have to master this. It's just I naught is equal to 1 times 10 to the power negative 12 watts per meter squared, which is just here. That is the minimum intensity of sound that the human ear can detect, and then the maximum is simply just 1 watt per meter cubed, and at and the frequency of that sound should be 1000 rather. Okay. Alright, so this is what I was just talking about, the intensity level. So again, about this formula, there's one thing that you need to understand. It's not always that they'll give you this yeah, so let me first explain the formula, and then I'll talk about what I wanted to talk about. So this beta is simply just the intensity in decibels, and then we have I, which is just the intensity of sound, and then we have I naught, which is just the threshold of hearing intensity, which is just this one here. Alright, so this is what I'm just talking about. So on this formula here, when they ask you to find the intensity given the intensity level there in decibels, you have to make I the subject of the formula. So this is where a lot of people find challenges. So I'll show you two ways in which you can do that, just by using rules of logarithms. Okay, so the formula is intensity level is given by 10 log I over I naught. So we make I the subject of the formula, and how do you do that? Simple. We can first divide everything by 10. So when we divide this side by 10, this side by 10, we're going to have intensity level over 10 is equal to, we have the log of I over I naught. So we can now use the rules of logarithms this side, which will just simply be this will be beta over 10 is equal to, we're going to have log I minus, since we're dividing two functions this side, so we're going to have log I minus log I naught. So we'll take log I naught to the other side of the equal sign, hence we just remain with log I on this side is equal to, then we have beta over 10 plus log I naught. So we can make I the subject of the formula. We change this to exponential form. So how do we convert that to exponential form? So the base of this log, since it doesn't have any base, means that it's already in base 10. So we're going to say I is equal to 10 to the power everything this side. So that is just going to be beta over 10 plus log. Of course, this logarithm is also in base 10, log I naught. So I'll put these in brackets. So now we can open the brackets, meaning we're going to have something like this. We're going to have I is equal to, this is 10 to the power beta. We're just applying the rules of logarithm. So it's just 10 to the power beta over 10. And then since there's addition here, it means that we are multiplying two indices with the same base. Of course, the base is 10. Then we'll have a log in base 10 I naught there. So remember those that I was taking in math last semester, I talked about if you have, let's say for instance, y is equal to e to the power ln 5, the answer is simply just y is equal to, you cancel this and that, and then you just remain with 5 as the answer. So I proved how this is equal to that. So those that follow me on my channel for mathematics, there's a way, there's a part where I prove that this is equal to that. Alright, so even here, the reason why, okay, let me explain based on this part. The reason why this is able to cancel with ln 5, so ln 5 is simply just, with ln there, ln is just a special logarithm with the base e. So as long as the base is just the same as what is there, you can simply just say this ln and that 5 goes. So since here we have this logarithm in base 10 and then we have a 10 there, so we can easily just say this and that will cancel, meaning the final solution or the final formula will simply just be I, so this will be I naught times 10 to the power beta over 10. So let me just write it properly. I is equal to I naught, open brackets, then we have 10 to the power beta over 10 there. So this is the formula when you make I the subject of the formula. So let us quickly use the other formula to find the same answer, and then you are going to pick whichever is going to be simpler for you. So the formula is beta is equal to 10 log I over I naught, and beta is equal to 10 log I over I naught. So we divide by 10 on both sides, we divide by 10, so we're going to remain with log I over I naught is equal to beta over 10. Then from there, the other thing that we need to do is we make this part here. We make this part here the subject of the formula. How do we do that? We just convert the whole expression to exponential, meaning we have this log which is in base 10 because it doesn't have any base there, meaning it's in base 10. So we say I over I naught, we say I over I naught is equal to, then we are going to have 10 to the power beta over beta, which is just the intensity level, over 10. And then apart from that, you can you can now say we can cross multiply here. So when you do the cross multiplication there, you're going to have I is equal to I naught multiply everything by 10 to the power beta over 10. So this one is quite even short. This is the shortest way you can do that. So it's just as simple as this. Yeah, so that's how you make I the subject of the formula. If you want, you can go further than that, where you just say I is equal to I naught multiplied by the 10th root, the 10th root of 10, then everything raised to the power b, which is the beta there. Yeah, but this one will just confuse you. Sorry for that. Okay. This one will just confuse you. Let me just do this. Okay. Yeah, so you can just end here. You just replace the intensity level there and find the final answer. Alright, so this is where we're going to end tonight. See you in the next lesson. Make sure that you don't miss out the lessons that I'm going to be posting. See you in the next lesson. My name is Harmtedy. Shalom, shalom.